Okay, so we have a bit of a complex session now. We're going to try to be as quick as possible. So the idea is everyone that's got a poster has 1 minute to give a quick summary of it. I'm going to be very strict on 1 minute. So when you're coming up, when the previous person to you is speaking, ask Maria here who can load up your poster and then be ready to go. So, and please introduce yourself when you're starting as well. Over to you.
Okay, thank you. So my name is Peter Breslin, and my poster summarizes the project I did for my master's thesis, in which large Earth-orbiting satellite networks, these so-called mega constellations, the interference from these is assessed in the context of ground-based optical astronomy. And we use a camera system called the multi-site all-sky camera. It's one of 2 camera stations developed through my university. And also this study is limited to the Starlink mega constellation due to its population size closely approximating the total size across all mega constellations at the time of this study. And yeah, so briefly, this poster summarizes the automated routines developed to track satellites, these Starlinks, and distinguish their trails from observational data and extract them. And then the interference is characterized by looking at the brightnesses of these trails. We look at the distribution of these brightnesses for the different types of Starlinks. And then also we project the level of interference into the future for expected sizes of these mega constellations.
Okay,
thank you.
Please go over there. I suggest if you hold your applause, we'll do a round of applause at the end. Next.
Let's see. Hello, I'm Adam Snyder. I'm a postdoc from the University of California, Davis. I work with the Rubin Observatory, LSSD camera. My poster basically is a study that we've been doing looking at challenges to detecting and masking streaks in LSSD camera images, with a focus on looking at possible systematics that can arise from this incomplete masking procedure. There's a lot of details that I have left out, so feel free to ask me about it, but we've come up with a number of recommendations for how to go about developing masking techniques in order to avoid potentially contamination in your science goals, in particular looking at bogus galaxy populations and bogus transient alerts that occur in the LSSD survey. Thank you.
Perfectly timed, thank you.
Okay, so thank you very much. My name is Katarina Sabolova, and I focus on material categorization and material aging of artificial satellites. In this work, we analyze the spectra of Iridium constellation satellites and how their spectra change over time. We use the EMOS camera, which is a camera with a spectral grating, and the data were acquired over the course of 6 years. We also acquired the spectrum of Iridium-33, which previously collided with a Cosmos satellite. And if you have any more questions, you can ask me, come to my poster, and we can talk. Thank you.
Hi, I am Sebastián Zúñiga. I am a postdoctoral researcher and the manager of Speculus South Observatory. So the Speculus South Observatory is a photometric survey for finding transients of planets in cool star. And recently we are, of course, start to see some traces in our images. So after a visit of Paranal, I followed the advice of my friend Angela Tarola to do a detection and characterization of these traces in our images. So this project is just starting. We detect these traces with our open source code and pipeline pros. So please let me know if you have any doubt, and also I am open to receive any suggestion to the way to detect and as well as store the data to be more useful for the community. Thank you.
Hello, my name is Hasmik Andreasyan. I'm research associate in Buran Astrophysical Observatory in Armenia, and also I work in software company called Tuparev Astrotech. And here I am presenting our project in Tuparev Astrotech. It's a joint project in partnership with Astrosystem Austria. It's a telescope manufacturing company based in Austria. We are developing our space situational awareness project, a space situational awareness system to track satellites and space debris. And my poster is dedicated for that. And the second project that I want to mention here is our application called Telescope Observer. And it's going to be like a Facebook for astronomers, and it will be ready in coming months. And we in Tuparev Astrotech open for collaborators and for new ideas, and of course also for help. So please come to me if you have some ideas, and also there is an email, and you can write and contact us. Thank you.
Hello, everyone. I'm Anatoly Ivansov, Royal Observatory of Belgium. The poster arises from the question what we can do in order to adapt our measurements to the star tracks that we are observing in the field of view. So if we have, can you please shift it a bit? Shift it a bit up. Sorry. Can you please? No. Up. Yeah. On figure 1, you can see an image profile undisturbed, and also you can see a small gradient arise from background, and you can see with the red one the profile of the combined both background and image that we can have, and it's hardly noticeable that the red peak is shifted a bit with respect to the blue one, and with the first derivative it is quite evidently seen. So actually I was lucky to find the solution how we can correct the shift of those two peaks, and on figure 2 and 3 with topographic map, for example, one can see that we can apply this analytical solution to any object that is affected by the background, and we can calculate what will be its shift in direction to the gradient. Thank you very much.
Thank you.
Hello, my name is David Baroc Lopez. I'm a software engineer at the TGO Robotic Telescope, which is located at the Montsec Observatory at northeastern Spain. The TGO telescope has been used for research programs since 2010, and recently it's being used also for space surveillance and tracking of satellites. As part of this, we've developed an algorithm to detect traces of satellites, which we applied to over 200,000 images stored in our database. As part of this, or as a result of this, we obtained that 1.3% of the images contain at least one satellite trace. And looking at the evolution over time, we've seen that the number of traces per hour and square degree has increased by a factor of 2.7, from 4 in 2017 to around 10 in 2023, which is compatible with the 2.5 increase in the number of low Earth orbit objects in the same period of time. Thank you.
Okay, we have one last one which is online. Eduardo, are you there?
Yes, bear with me 1 second. Okay. Can you see my screen?
Yep, you're good to go.
Okay, sorry. So my poster is about some experimental procedures for satellite modeling. Basically, I start with a presentation of the Koirama Observatory, which is the observatory of the University of Antofagasta, which has participated in some key campaigns already, the observation of DarkSat, observation of VisorSat, and also some modeling of new satellites such as the Blue Walker 3. And the upgrading that is being brought to the observatory in 2024, in which we are going to include a new satellite tracking station so that we will be able to take many pictures or many images of the satellites during a flyby, changing filters and so producing different color analysis. Finally, we're also working on refining our modeling technique by developing a new device that will allow us to test space-grade materials so that our BRDF are based on more solid evidence. We are welcoming any space-grade materials you can contribute to us. Thank you very much.
Okay, and thank you to all the poster presenters.